this chapter ionic equilibrium. Okay. So you'll realize that those indicators are also either weak acids or weak bases themselves. Okay. And you need not know much about it, but I'll just tell you something. Like suppose like HCl is acid, say indicator is HIN. Okay. IN is the anionic part of the acid. So the cool thing about an indicator is when it is HIN, when it is this molecule, it is of a certain color, color 1, and when it breaks and forms H plus, which is obviously colorless, and the indicator minus aqueous, this is of some other color. Okay, so whichever weak acids we have got, who or which exhibits two different colors, one as a whole molecule and one as just the anion of a different color, those can serve as indicators. Is that clear? So it all depends, like you have put in a certain solution. If you have put in a H plus solution, whatever I'm saying may not make much sense because it is all part of ionic, and you will understand it again when they teach you in ionic equilibrium. When you put this indicator in a solution which is already having a lot of H plus, what is going to happen? Due to the presence of H plus already, this is not going to go forward. The reaction will be very less forward. It will be mostly backward. That means this will remain intact and the color 1 will be exhibited. Say yellow color will be exhibited. Okay. Wherein if you put in a solution which is say basic or something, then it is going to react and the H plus is going to combine with the OH of the base and the reaction will be pulled forward, and hence this will come into the picture, this will be gone. Okay, and you'll have this color. So you will understand that okay, the reaction was sorry, the solution was basic. Okay, so that's a rough idea. Okay, you have a very precise calculation on how much of this, how much of this, using the K value of the reaction. So which you are going to do in the indicators chapter. So in the ionic equilibrium chapters, I'm not going to delve into that much. With respect to stoichiometry, it is pretty straightforward. Okay. So indicators are very many. Lot of them are there. I'm just going to talk about phenolphthalein and methyl orange. Okay. These are the two indicators I'm going to talk about. And obviously, as I said that they are themselves either acid or bases. Okay. It is not that when a solution is exactly neutral, that means when the pH is 7, that time they will show a color change. No, it is, that's the impossibility. It's not maths which is happening. Okay, it's actual science which is happening. Is that clear? So for now or for today, what you need to know is this phenolphthalein shows a color change when it is slightly basic. Okay, what is that? pH is roughly equal to 8, 8.1. Okay, is that clear? Is that clear? When the solution is basic, this indicator will show a color change, meaning to say you had a proper base, say NaOH, NaOH solution, aqueous. Okay, you put some drops of phenolphthalein, put some drops, and is going to turn the whole solution pink. Is that clear? Is that clear? Because it is in base, and phenolphthalein shows pink color in base. Okay, because of which molecule and all, you don't have to care. I will not even speak about it right now, even though it is something very easy, so that your attention is not on that part. Okay, now if I start titrating it with some acid, say HCl, drop HCl, I'm just putting, what is happening? NaOH is getting neutralized slowly. Okay, And when it is fully neutralized, that is a pH 7, right? But phenolphthalein will say that it is fully neutralized, or phenolphthalein will indicate a color change when it is pH 8. That means still some NaOH is remaining and HCl is still a little more you should be giving. Okay, it is going to show a color change, and from pink it will turn to, yes guys, which color? Colorless. I hope you know that, right? It was there in your 10th. Okay, is that clear? Is that clear?
Yes, sir.
Is that clear? So generally, I was working on ships and all. We used to do a lot of things. Okay, uh, and even with chemicals, we had to do a lot of things. Okay, particularly if you are on old ships. Now modern ships, it is a different story. You don't have to do anything. So we used to do the testing, and generally the thing was, okay, when phenolphthalein has showed a color change, we will just put one or two extra drops, depending on which container, which size of container we are doing. We had a slight idea. So extra drops. Why? Because we know that still it is still little basic, and little more acid is going to bring it to the neutral position. Is that clear? Is that clear? So do we have indicators for exact 7? Yes, we have some indicators. Okay. Thio, bromo, some indicators are there. Okay, you'll be learning those. Your chemistry teachers will teach you that. Okay. So methyl orange also shows a color change, but unfortunately, it shows a color change when it is quite acidic. Okay, it is going to show a color change in the range of pH is 3 point something. Okay, I'll just write 3.5 or so. So it has become really acidic, and then it is going to show a color change. Is that clear? Is that clear?
Yes, sir.
Get the point? So
Yes, sir.
generally when we are neutralizing and we have to figure out uh, unknown sample of say NaOH was there, unknown sample, okay, large amount, you have liters and liters of it. Okay, we'll take a small amount from there, say 50 ml will take or so, 10 ml, 20 ml, whatever we are going to say, take. And then we are going to neutralize with a known molarity, say 0.1 molarity HCl. We are going to neutralize. We are going to check how much of volume was used. So knowing the volume, say volume is 20 ml used, and knowing the molarity, we would come to know what is the number of moles of NaOH in this 50 ml. Is that clear? Is that clear? But then, how do we know that it is neutralized? There has to be some indication, right? So there are various ways. Okay, through electric current, through potential, lot of things you can do to be really precise on where it is neutralizing. Okay, so one of a very rough way is using the indicator, because it is one of the cheapest way. Okay, so you'll put phenolphthalein, you'll get a certain reading, okay, say of 20 ml, but you know this 20 ml is not right, right? Get the point? So you'll note down this value, and perhaps you keep on putting more, and you put methyl orange as an indicator, and say when the volume of say 25 ml is put, then methyl orange also shows a color change. Okay, so it will indicate that yes, now the pH has gone to this level. Is that clear? Is that clear? Is that clear? Is that clear? So
So
what
at
I'm
what
saying
pH?
is,
So at what pH level does the methyl orange change color again? I didn't understand that.
what?
So at which pH level does methyl orange show the color
3.5.
change?
3.5. So you only need to know for this chapter, you need to know that if you are going from, sorry, if you are going from a basic solution towards acidic solution, okay, and say this is the real neutral point, okay, and this is your, the solution has got a pH of 7, then if I'm using phenolphthalein, it is going to show a color change somewhere over here using phenolphthalein. Is that clear? And if I'm using methyl orange, it is going to show color change somewhere over there. What are the values? Like I wrote a 3.5, 8.1 is immaterial. Okay. For stoichiometry chapter. Is that clear? You really
Yes,
don't
sir.
know, need to know the value. Okay. But just for your general knowledge sake, 3 to 4 pH. So I'll just write 3.5 and 8.1, 8.2 ish kind of pH. Okay. Is that clear? Is that clear? You need not know this value.
Yes, sir.
Understood? Okay. So I will now present a certain question to you. Acha, guys, anybody from NPS is over here today? NPS, anybody? You need not be here because I've done this in your school. Okay. I took no 15 minutes or something. I done. If anybody is from NPS, you may leave the meeting. Okay. Because I have already done. If you still want to see, you can see. Okay. Okay. So
Sir, other than phenolphthalein and methyl orange, are there any other indicators we need to know?
no, not for this chapter. Okay. There's a bunch of indicators which we'll be teaching you when you come to ionic equilibrium. Okay. And
Okay,
there
sir.
we'll have to be very precise of which species, which ion is how much in the solution. Okay. In this chapter, we just assume that so much of acid has neutralized the base and it is really neutral. Okay. And since you have asked something, I'll just tell you one thing. The difference between this chapter and ionic equilibrium chapter. Okay. In this chapter, suppose there is HCl plus say NaOH. Okay. Say you had 10 millimoles of NaOH. How much of HCl is required to neutralize it? 10, right? Right or wrong? And
Yes,
NaCl is
sir.
formed, H2O. Okay. It is a monoacidic base. This is a monobasic acid. One required one. And that's it. This H plus went and joined with that OH minus, became water. And this Na plus and Cl minus is floating about, became nothing. But we just write it as Na plus Cl minus aqueous. Okay. This has actually joined and become water. This has not even joined, has become nothing. Okay. Is just floating around as Na plus and Cl minus in the solution. If we evaporate the water, then yes, those Na plus and Cl minus will come together and we may find crystals of the salt. Is that clear? Now, if I take another monobasic acid, CH3COOH. Now I think it will take more than half an hour. Oh, it is already 7:50. Oh my God. It will take more time. Okay. NaOH. Say there were 10 moles. Okay. One reacts with one. So 10 will react with how much? 10 will react with 10. Right? And it will form what? CH3COONA and H2O. Okay. So we'll say that we require 10 acid to neutralize 10 base. Okay. And this is what is formed. But the point is, with 10 acids neutralizing this, what is formed is actually still it is basic in nature because this was a strong base and this was a weak acid. So if you take equal amounts of weak acid and strong base, the solution is still basic. Okay. In the point, and this is not 10 moles of this is not a pH equal to 7, wherein 10 moles of this is pH equal to exactly 7. Now, this kind of deep study and research work happens in your ionic chapter. Okay, that's the point of the chapter. Is that clear? That even if I'm giving you a salt, full salt, still how much is the pH? Okay, so this pH will come slightly more than 7. Is that clear?
Yes,
Wherein
sir.
the pH over this will come as 7, right? And hence those indicators are actually neutralizing where will become a big part of that chapter. Now in this chapter, it is pretty straightforward. So when I give you the question, you will understand what I'm talking about. So you really don't have to care that at which point it got neutralized and all. Okay. So we say when the solution is slightly basic, still basic, phenolphthalein will show a neutral point. But when we are very sure that all the base is gone and it is only acid remaining, then only methyl orange is going to show a color change. Is that clear? Is that
Yes,
clear?
sir.
When it is on a dicey point, methyl phenolphthalein will show a color change. When it is fully acidic, then methyl orange will show a color change. When it is a dicey point, then phenolphthalein will show a color change. Okay, so let's see a question and try to understand that. Okay, guys, everybody can see this question in front of you.
Yes, sir.
First, read properly and give it a go. Okay, if you give it a go, understand, absorb the question, then when I speak, it will make more sense. Whether you get the answer or not is immaterial. Okay, all stoichiometric questions are like a small puzzle. You have to figure it out. So as I told you last class, make some bubbles and or visually represent things in front of you. Okay, and figure it out. Okay, got the answer. Got something anybody wants to say? Let's do it now. Anybody? Anything? A solution of NaOH and Na2CO3 is prepared. Okay, well and good. Are they going to react with each other? Yes, guys. You should have your thinking cap all the time on. Okay. So are they going to react with each other? Obviously not. Why not? NaX plus NaY. Even if it reacts and displaces, this goes here and this goes there. What is formed? NaX and NaY, right? Cation is same. So what? There is no question of any reaction over there. Is that clear, guys? So yes, you can mix and prepare. Is prepared 20 ml of this solution required for neutralization. Okay. So they are using HCl 0.1 molar and 25 ml is required with phenolphthalein. Okay, well and good. So if they use methyl orange, then it should have required how much? More than 25 or not? More than 25 or not? Guys, are you there?
Yes, sir.
You have some basic mixture and you are neutralizing with acid and you are using phenolphthalein as the indicator. So you see that, okay, 25 ml is consumed. Okay, well and good, 25 is consumed. We know that this from its journey of base to being acid, and this is the neutral point. When you keep on putting acid, the pH goes towards the neutral point and phenolphthalein is going to show a color change. So 25 ml you have put. So for methyl orange to show a color change, you should have put more, right? Right or
Yes.
not? Yeah, so we are happy that, okay, we understand the data. It is consistent, we understand the data. Unless until you understand the question, don't even think of starting to solve the question. Okay, and the worst part
Sir,
will be that without understanding the question, if you get the answer correct, then you will think that, okay, you know how to do the question, and for sure in the exam you will not be able to do. Okay, so without understanding the question, you should not be solving the question. नहीं नहीं प्लास्टिक वाला नहीं है क्या इसमें मुड़ जाएगा इन लोग के पास प्लास्टिक एनवेलप है ना एक वो दे देना okay yeah somebody is saying something
sir, in this question, aren't we adding base to the acid? Like we already have acid and we're adding base to it.
no we have the base NaOH and Na2CO3 it required so much for neutralization so this is the 25 ml is it not very obvious you can add anything to anything by the way but here it is clearly said it is 25 ml of the solution okay of the NaOH plus Na2CO3 mixture. Now you are trying to neutralize it with some when phenoxy is used as indicator, itna when phenoxy required for neutralization, this solution required for neutralization. It required 25 ml of HCl for neutralization. Okay.
Oh, okay.
Okay. Hmm? Is that clear? Even if you understand the other way, it doesn't matter much. Okay. Hmm? The math remains the same.
Yes, sir.
Okay. Is it clear, guys? Is it clear? Is it clear?
So, can you explain this question once again?
Now, what?
Can you explain this question once again?
Yeah, tell me what you have understood in the question.
Sir?
Tell me what you have understood of the question. What have you understood of the question?
Sir, like what I've understood from the question is that these two things, NaOH and Na2CO3, will not react. I mean, that's all I've understood.
No, no, read it. No, a solution of this and this. That is what I told they will not react. Okay. Hmm? You read the question and tell me what you understand. A solution of NaOH and Na2CO3. So, do you understand this line? A solution of this. What do you mean by this? Tell me.
Which means it means that like NaOH and Na2CO3 are like mixed in water and
Yeah, okay,
made a
correct. They are mixed. Okay. So, we have a mixture of NaOH and Na2CO3. Then read further. I just started reading for you. Is mixed and prepared. Full stop. Then
25 ml of the solution is required for neutralization.
yeah, slowly, slowly. So 25 ml. So 25 ml, right? Is it okay?
Yes, sir.
Is required for neutralization. 25 ml of this solution required for neutralization. Required for neutralization. You can really add at the end over here. Okay. They did not want to use it twice while typing. Therefore, they have written like this. 25 ml of this solution required what?
So 25 ml of 0.10. So is that normal or molarity?
Yeah, you can take the normality as molarity for HCl. In the stoichiometry first chapter, first part, it would have been done that normality is X factor into molarity. Okay.
Yes, sir.
X factor for an acid or a base is how much H plus it has got or how much OH minus it has got. Okay. Like HCl, X factor is equal to 1 because it has 1 H plus. H2SO4, X factor is 2 because it has got 2 H pluses. Okay. H3PO4, X factor is
3.
3 because it has got 3 H pluses. H3, now chemistry comes, H3PO3 has got an X factor of 2 because it is improperly written like this. The acid is actually H2 and HPO3. Only these two are detachable. This H is not detachable. That is true. So they just bluff, just to bluff. They can sometimes use this, but it's a very common bluff. Again, I'm not going into this because that's a part of your chemical bonding chapter. I'm just concentrating on the maths part, what is required today. So if they give you normality of NaCl and molarity of NaCl, it's the same because your X factor is 1. Is that clear?
Yes, sir.
Okay. If you have done equivalence, then equivalence means normality into volume. Okay. Number of moles means molarity into volume. Okay. And the point is equivalence means X factor into number of moles. So this I will take another lecture on what does equivalence mean. Okay. Basic lecture on equivalence some other day. Is that clear? So today it is not even required. I can change the question for you if you wish to molarity. Okay. Is that clear?
Yes, sir.
Okay. So what do you not understand from there onwards? Tell me.
Sir, I didn't understand like how to solve the question.
No, that is a different thing. What is the question? Have you understood?
What is the question that I've understood?
Yeah. What is it? So this is a base and some 25 ml of some known HCl, 0.1 molar HCl is being used to neutralize the base. Is that clear? Now it is like a small puzzle. Can anybody tell me why it is showing neutralization with HCl, only 25 ml being used with the phenolphthalein, and with methyl orange, it is using 35 ml of the same molarity, 0.1 molar HCl, to neutralize. Okay, so what may be, so it is like a small puzzle. Okay, so these are the two things HCl is reacting. In my last class, we have already done what? In my last class, we have done that there was a Na2CO3 plus HCl kind of reaction. We have already indicated that it is kind of a base, right? There was some question done on that. Okay. So HCl reacts with this. Yes, well and good. HCl reacts with NaOH. So now you can be little adventurous and propose any proposal. Okay, you give me any proposal that why with phenolphthalein it is less HCl is required, and if it is a logical proposal, I'll accept it. It may be right or may be wrong. I'll give you the right one. That is your chemistry knowledge. So I don't expect a chemistry knowledge. I want a logical proposal that with NaOH it took 25 ml of HCl. Sorry, with phenolphthalein it took 25 ml. With methyl orange it took 35. Yes, who is speaking?
Sir, Ryan.
Name?
Ryan.
Yeah, Ryan. Tell me.
Sir, because for methyl orange, it needs to become much more acidic before the color changes, John. Like it needs to neutralize and
Okay.
then become acidic also. So you
Okay.
need more of the acid.
Okay. Good answer. Good answer. That means you're understanding what it is, what's happening. But wrong answer, because it is assumed that even if I put 1 ml extra HCl, okay, the pH just swings. Okay, are you understanding? So it's not like 10 ml and all. Okay, once it is neutralized, 1 or 2 extra ml of HCl, it is just going to, once the reactions are over, a little extra HCl is just going to make the pH go drastically near to 1. Okay. Hmm? And it may ultimately become less than 1. So your proposal is logical, but it is wrong proposal. So reaction wise, there is two different things happening. Okay. So any
Sir,
other proposal?
Sir, this is Kavya here, sir. I think like is it because like the pH, see the pH of phenolphthalein and methyl orange itself is very different. So like you have to neutralize phenolphthalein and
No.
methyl orange.
Indicators, okay, nice. Okay, maybe methyl orange it was itself was a base. Maybe phenolphthalein it was itself was a base, which it is not, by the way. And the some HCl is going to neutralize that indicator itself. So nice proposal, but wrong. Okay, it is the previous proposal was a little better proposal than this. Okay, no offense. Indicators you just use one or two drops. Okay, and there's absolutely either weak acids or bases. So those one or two drops will require 1/10 or 1/100th of a drop of HCl to actually uh, react with that also, if you have to consider. So it is negligible. Okay, indicators are negligible amount and it doesn't consume the main reactants. Okay, so nice thinking hat is there. So I'm pretty happy with both of your answers. I'm telling there's some basic change, I mean basic difference in the reactions itself. Okay,
Sir, sir, because like according to the if you like try to balance the reaction, then like we will require like two moles of HCl to like actually go for the neutralization, whereas that's for Na2CO3, and for NaOH it like just requires like 1 mole or 1 part.
so I don't get that. So
So what
it's a
that means is
mixture of
like,
both. Yeah.
so what that means is like you if you want to like neutralize the whole thing of Na2CO3, the Na2CO3 as well, then you need like 2 moles of HCl.
Yeah.
So which means that we need like more HCl.
So what are you proposing? Like when we were neutralizing with 25 ml, it neutralized only this, and the remaining 10 ml neutralized that. Hmm? What is your proposal? I'm not getting your.
Sir, what I was trying to say was like, no, okay, sir, it's completely wrong. What I was about to say.
No, it's okay. You can express, but I'm not getting it. So if you want to elaborate on what you're saying, okay. Anybody else?
Sir, is it because there may be more Na2CO3 in the mixture?
Yeah. So
Sir, the weak base takes a little more time to dissociate.
no,
Sir,
nothing
does
like
it
that.
have something to do with sodium bicarbonate?
Yeah. What is that?
Sir, I'm not sure, but I have a feeling it might have something to do with that. Because it's a weak base.
So when you do
Okay.
it the first time,
Yeah, it is something to do with
NaOH,
that. Okay, so I was expecting one of the proposal to be that obviously these are two different compounds. Okay. Hmm? Maybe when HCl has reacted with, looks like this is more of a base, so it will react with this first. Okay. Hmm? And this is still remaining, and this has fully neutralized, and this is like weakly basic. Phenolphthalein is going to show a change. Okay. And when HCl has reacted with both of it, okay, whether it is two requires one or one requires one, that doesn't matter. When it has reacted with both of it, then methyl orange is going to show a change. Are you getting the point? I was expecting something like that, and that would have been a very logical explanation. But what actually happens is it is kind of you have to know this. Okay, that's the chemistry part. Okay, that your HCl is going to react with NaOH for sure. It is one Na only, so in one go it will get replaced with the H. So HOH is called water. HOH, so H2OL, right? And Na with the Cl is NaCl. Okay. Hmm? When HCl reacts with Na2CO3, then obviously first one Na is going to get replaced. When one Na gets replaced and one Na comes over here with Cl, what will that form? NaCl, obviously. Okay. Aqueous, which means Na plus and Cl minus just floating around. And the H is going to go over there instead of Na. So NaHCO3. Okay. Is that clear? So this HCl has also neutralized this kind of a base, but not fully. And when so much happens, phenolphthalein is like fully satisfied that yes, things are neutralized. Okay. Are you getting the point? Are you getting the point?
Yes, sir.
This thing is fully neutralized for sure. And this Na2CO3, I'll have to look up for the values, would have some pH of around say 9 or something. Okay, I don't know how much. Okay. The pH value of this may be 9-ish. Okay. So with this, phenolphthalein is not going to show a color change. It will remain pink. Okay. Get the point? But then when one of the NAs is replaced with H, one of the NAs is replaced with H, it has become less basic. This is basic. It has become less basic. Perhaps the pH has become, and it is NaHCO3, one H has come, so it has become more acidic or less basic, and it is still a base. Perhaps the pH has become a 7.7 or something. Okay, something like that. Is that clear? Okay, or 8. Is that clear?
Yes.
But then phenolphthalein just shows a color change when it passes 8. That means it is still basic, but not that basic as Na2CO3 was, and phenolphthalein shows a color change. Is that clear? So what you have to memorize as a chemistry knowledge is phenolphthalein is pink in Na2CO3 and phenolphthalein is colorless in, so you can note it down. Okay? Phenolphthalein is pink in Na2CO3 because it is quite basic, okay, with respect to phenolphthalein as an indicator. But phenolphthalein is colorless in NaHCO3, sodium bicarbonate. Okay, is that clear? So this is a chemistry knowledge. This you cannot have just I mean, this nobody can state for sure unless until they have the values. Okay, but you could have proposed this. Okay, get the point? Is it clear now? Is it
Yes.
clear what is happening? Okay. So phenolphthalein has shown a color change till the reaction written above. Then you keep on adding HCl more, and this NaHCO3 also, the other Na also gets replaced by the H. Okay. So I can write it as like NaCl plus H2CO3, which is literally like H2O plus CO2. Okay. Is that clear? So this is like methyl orange is also going to show a color change when you are at this part. Okay, because this will take you to the region of being totally acid. Is that clear? Is that clear? Or even if you
Yes.
say this is neutral, half a drop of extra HCl is going to make it totally acid. Okay. Get the point?
Yes.
Get the point? Okay, so this is the premise and this is the knowledge. Now comes that, okay, I am understanding what is happening in the question. Now comes how to solve the question. So shall I solve or will you give it a go? The chapter is mole concept. So have a very tight hold of how many moles. That will give you a good idea of how to solve. So we have not started with the solution. As I said, unless until you understand what is happening, just randomly giving some solution doesn't help. Even if you fluke the answer, it is even more dangerous. It gives you wrong concepts. Okay. Now, any proposal of solving the question? Any proposal? Since it has taken too much of time, I really have to go. So I will just solve it for you guys. Okay. I'll give you another question to solve. This one I'll solve it for you. Okay. Is that okay?
Yes, sir.
Okay. So in this 25 ml of the solution, I'll just assume that we have got X millimoles. I like to work with millimoles instead of moles. Okay. Because we have milliliters and all. You can say X moles also. Okay. X millimoles of NaOH, which I don't know. And I've got Y millimoles of Na2CO3. And X and Y is what we have to find. Is that clear, guys? Is that clear? Okay. Now, when the first reaction happens, one HCl reacts with one NaOH. We are saying it is X millimoles. So X will react with how much? X will react with how much? X or not? Right? Right? And for phenolphthalein, I'm saying it does this reaction. It just gives a bicarbonate. So when we balance it, how much it is? One reacts with one because one H replaces one Na. Okay, one reacts with one to give one of this and one of this. That's the balance reaction. Okay. So this I'm saying is Y millimoles. How many HCl it reacted with? For a phenolphthalein to show a color change, how many it reacted with?
One.
Y, right? Right? So how much of HCl is consumed? For phenolphthalein to show a color change, how much of HCl is consumed? X plus Y, right? Right or not?
Yes.
Yes,
But
sir.
they have given how much of HCl is consumed. So we have no mystery. X plus Y is equal to how much it is? 25 into 0.1, right? Molarity into volume. Those who were there in the last class would understand that, right? 25 into 0.1. How much is that? 2.5. One equation done, right? Right? Similarly, using the other information, we can make one more equation, right? And we have two equations, two variables X and Y, we'll get the answer, right? So the other equation, please make.
Sir, shouldn't you convert ml to liters first?
Were you there last class?
No, sir.
Number of moles is equal to molarity into volume. Okay. If volume is ml, then you get your answers in millimoles. If volume is liter, you get your answer in moles. Is that clear?
Yes, sir.
For example, molarity was suppose 1 and volume was say 50 ml. How many millimoles? 50 millimoles. Is that clear? 50 millimoles means 50 by 1000 moles. I could have converted this to liters. Molarity is still 1 into 50 by 1000 liters, and I straight away get 50 by 1000 moles. It's the same thing. Is that clear? Is that clear? Simply, if you multiply with milliliters, you get millimoles. Okay. Molarity unit is moles per liter or millimoles per milliliter, and the value remains same.
Yes.
2 molar means 2 moles per liter is equal to exactly 2 millimoles because of factor of 1000 per milliliter. 2 only. Okay. So when I multiply
Yes.
with liters, this thing, I get moles as the answer. When I multiply with ml, this thing, I get millimoles as the answer. Okay. What's the other equation? I may continue as I have written, or I may take it as a fresh situation. Okay. That 35 ml was required when the reaction happened. Okay. So as a fresh. Why is it, man? Why is it not writing? Okay. Yeah, as a fresh situation, I can just rewrite everything. I don't have to, but I'm just rewriting that HCl reacted with NaOH, gave NaCl plus H2O. HCl reacted with Na2CO3 fully, not part reaction, gave NaCl plus H2O plus CO2 or H2CO3. I'm just writing. Okay. I'll balance both. One required one to give one and one. Here, two reacted with one, right? To give two of this, right? Is that clear? And one of this. Is that clear?
Yes, sir.
Those are the balancing, right? Right? We are saying that we had X millimoles. We had X millimoles of NaOH. So how much HCl it consumed? X. We are saying that we have Y millimoles of Na2CO3. How much HCl it consumed?
2y.
2Y. So what's the total HCl consumed?
X plus 2y.
X plus 2Y. But then they have said how much is the total HCl consumed. It is 35 into 0.1, which is how much?
3.5.
3.5, right? So we got our second equation. Okay, solving the two, we get our answer. That means if you subtract 2y minus y is equal to y is equal to 1 is what you are going to get. You put in one of it and x is equal to 1.5 is what you are going to get. Okay. Millimoles, they are asking the answer in strength. So you convert the millimoles to what? Is it clear, guys? This is solved. Okay. Then they can ask the answer in anything. So just to finish off the question, I'll just tell you. Do you want to note this? Is it clear? Is it clear?
Yes, sir.
Is it clear? So how many grams of NaOH was there? NaOH in grams, it was, first we'll see the moles. It is 1.5 by 1000 moles into the molar weight. Okay, so many grams of NaOH was there. Is that clear? Grams. How many grams of Na2CO3 was there? We'll see the moles, 1 by 1000 moles. And each mole has got a weight of 106. So many grams. Okay, what do you mean by strength? Grams per liter. Is that clear? So if I have to write the strength, I'll divide it by liters. So how many liters? It was in 25 ml. So 25 by 1000 liters. Is that clear? 25 by 1000 liters. So this 1000 is going to cancel with that 1000. So that is your calculation pretty much. Okay, 1.5 into 40 divided by 25. Okay, whenever you see a division by 25, just multiply 4 on top and 4 on bottom. What do you get? 1.5 into 40 by 25. I see 25. I'm so happy. I multiply 4 here. I multiply 4 there. This becomes a 100, right? Is that clear? And on top, 4 into 1.5 is a 6. 6 into 4 is a 24. So 640 divided by 100. So 6.4, right? Is that clear? Is that clear?
Yes, sir.
Yes, sir.
Yeah. So the calculation, but obviously we are not doing maths, so you understand that. Okay. Main thing was over here. Okay. Any doubt you ask me, because I'm going to show you a question and you have to do it like this in one go and fatafat. So any doubt you have, please ask me. While NaOH is there, phenolphthalein will be pink. While Na2CO3 is there, phenolphthalein will be pink. If NaOH is gone, phenolphthalein will show a color change, provided Na2CO3 is also gone. NaHCO3, it has become, phenolphthalein will show a color change. Okay? Okay? NaHCO3, phenolphthalein is colorless. Okay? Any doubt in this? You ask. Ask. Look very closely. Ask. I'll come back to this window. For the others, I'll just give you the question. Those who don't have a doubt, do this question.
Sir, sir,
Yeah,
why are we
others
adding?
just take a snapshot of the screen, note this question, and start doing it because I'll go back to the previous question for the people who are having doubt to ask. Yes, people ask.
Sir, why are we adding less HCl in the first the one the when phenolphthalein is used?
I did not get the question.
Like in the when we use when phenolphthalein is used as indicator, then we're adding like only 1 mole of HCl, right?
1 mole of HCl, we are adding 2.5 millimoles of HCl. 25 ml of 0.1 molar HCl means 2.5 millimoles of HCl.
Okay.
Why do you say 1 mole of HCl? Tell me. This is a reaction ratio. This may mean 1 kilomoles of HCl reacts with 1 kilomoles of NaOH. It may mean 1 molecule of HCl reacts with 1 molecule of NaOH. This is the ratio. If this is 1, how much is that? I can also write it as 7 reacts with 7. But generally we want to write simple ratio. So we write 1 reacts with 1. It,
I'm in the ratio only. I'm in the ratio.
yeah, so it doesn't mean that there is 1 mole of HCl given. 1 mole reacts with 1 mole. It doesn't mean that there was 1 mole. Are you understanding?
Yes,
So
sir.
what's your question?
And why is the reaction ratio different for when different indicators is used?
No, it is not. Which reaction? Read out the reaction and ratio is different. Tell me which reaction ratio is different.
Right? Or the reactions are only different, right? So why are the reaction? Shouldn't it be the same reaction because you're adding the same substances, right?
Yeah, your question is little flawed. Okay, if you ask your question properly, I am pretty sure you will get your answer. So you ask your question properly. You are saying the reaction is different. So I dismiss that statement totally. Is this reaction and this reaction not same?
Yeah, so that's the same, but the other one when it's reacting with Na2CO3.
And when it's reacting with Na2CO3, the reaction actually happens in 2 steps. What do you mean by a reaction?
Oh,
Okay, this reacts, one
okay.
HCl reacts with one Na2CO3 to give one of this and one of this. Is that clear? Then
So, but then that
this one can again react with an HCl to give you this and this. If you add both, you get this. Okay. But while it is happening in 2 steps, it's like you are climbing 2 steps. Okay. But while you are climbing 2 steps, when you have climbed 1 step, then phenolphthalein is going to show that, oh, you have climbed 1 step. Okay. Why? Methyl orange is going to go show that you have climbed the steps when you have climbed both the steps.
okay, sir, I understood.
So can you explain that again?
Yeah, tell me what. You tell me, you frame your question properly.
What you just explained right now, the
No,
phenolphthalein and
you have to have your own question and you'll have your own customized answer. Okay, from my side. You have to have your own question. What is your question? What is your doubt that you have to say properly?
how phenolphthalein shows the step compared to how methyl orange shows the step.
Okay. While going from basic to acidic, phenolphthalein will show a color change while it is still basic. Have you understood that?
Yes, sir.
Is that clear? Okay.
Yeah.
Na2CO3 is a base or an acid?
Could you repeat that? Your voice was breaking.
Na2CO3 is a base or an acid?
Oh,
Everybody listen to this properly. Those who have little doubt or little whatever doubts, okay? Because if you have this doubt, you rather listen to my answer. Yeah, Na2CO3 is a base or an acid?
base.
Yeah, it is a base. The reason is, yesterday I was telling them, because it is thought to be made of a strong base and a weak acid. Weak acid, I was just telling them that this is something what you can drink, it is soda. And if you drink this, you die, okay? So it's a mixture of these two, a strong base and a weak acid. So this is actually a base, okay?
Yeah.
Okay, very well. Now, in any base like NaOH, I replace the cation with a H. What happens? It loses its basic nature a bit, okay, or totally. Is that clear? Is that clear?
Yes,
So
sir.
NaOH is Na plus NOH, but if I replace that Na with a H plus coming from some acid, HOH is the water, is no longer a base when the Na is replaced. Is that clear?
Yes, sir.
Is that clear? Okay. So my next question is, Na, two NAs were there. One Na is replaced with the H, CO3. Is it more acidic than Na2CO3 or more basic than Na2CO3?
More acidic, right?
More acidic, right? Because the H has come in, right? Is that clear? So it is less basic, right? It is less basic, right?
Yes, sir.
Okay, this still happens to be a base because it still can react with more HCl. Something which can react with an acid is a base. There is one more Na to be given away and H to come and replace. So it is still a base. Is that clear? But we are pretty sure that between the two bases, this is more basic and this is less basic. Is that clear? Okay. So in this base to acid scale, if I have to place Na2CO3, now this is your chemistry information, it is somewhere over here. Okay. Okay.
Yes, sir.
And this is basic, it has to be left side of the neutral point, but it is not too left. This guy is somewhere over here. Is that clear?
Yes, sir.
Understood?
Yeah.
And when this Na is also gone and it becomes H2CO3, then that is like somewhere over there. Is that clear?
Yes, sir.
And you don't have to know the values at all. Is that clear? But
Yes,
what
sir.
you need to know is that when Na2CO3 becomes NaHCO3, phenolphthalein is going to show a color change. It is passing the phenolphthalein point. Is that clear? It is called end point, and we'll be actually teaching it in detail in ionic chapter. Okay, so it passes the end point of phenolphthalein. Is that clear?
Yes, sir.
What's the point? Okay, so now having the story clear in your head, then you should be just looking at the equations and all. That O, if it reacted with Na2CO3 and replaced only one H, which is the first reaction, then my phenolphthalein is going to show a color change. And had it replaced the other H also, okay, in the point, then H2CO3 will show a color change. Okay, in the point.
H2CO3 also color change.
Sorry, phenolphthalein will show the color change.
Okay.
Okay, is that clear?
Yes, sir.
So I can say that after reacting YHCl reacting with Y of Na2CO3 gives Y amount of this. That Y amount reacted with another Y amount of HCl for a complete reaction. Okay. And the total HCl consumed for the complete reaction is Y plus Y. Y replaced one Na and another Y replaced another Na. Is that clear? And hence, in totality, just to make the equation, these two equations little simpler, it is a 2Y, which has reacted with Na2CO3. Okay, for methyl orange to show a color change. Is that clear?
Yes, sir.
Okay. So if it is clear, everybody should be able to do this. And since I've given enough time for the others to do, I'll just do it and end the class today. 8 grams of a mixture of anhydrous la. Okay, was dissolved. Okay. This time there is no NaHCO3. So somebody just tell me what is your answer, and then I'll see. I'll be happy if any one of you have got an answer to this. Strength. Answer. Anybody? Got an answer?
So
Anybody? Or X and Y answer?
so
Yeah.
I'm not sure, but I think X is 0.0012 and Y is 0.
Yeah, you can tell me in millimoles. Yeah, how many millimoles?
12 and 8.
Huh?
8 and 12.
18?
8 and 12.
No, I think you've got it right, but you're just little here and there. It is 1.2 and 8. Okay. 0.8. 1.2 and 0.8. Okay.
Yes, sir. Even
Your 1000 ka factor mein you're just doing a little error here and there. I'm happy with your answer. Okay. I hope it's the right ones. So I'm happy that somebody could do it. So I'll just do it now. So suppose your Na2CO3 was X millimoles and NaHCO3 was Y millimoles. Okay. Dissolved in so much 25 ml of this solution is taken lala. Oh, so you have to do that little bit of unitary method later on. Okay. I'm saying X and Y in this 25 ml. Okay. So in 100 ml, how much it will be? 1000 ml, how much it will be? 40 times this. Okay. 40X and 40Y. Okay. So they just try to stretch the question by taking all this thing as I was explaining in the last class. Okay, with methyl orange, it took 32 ml. With phenolphthalein, it obviously took lesser. So let us just start with phenolphthalein. So phenolphthalein is showing a color change in what reaction? NaHCO3 doesn't even have to react, and Na2CO3 is just reacting partially, like only NaHCO3 is getting formed. Right, guys?
yes, sir.
And it is showing a color change, and the other reaction is not even happening in part B. Other reaction is not even happening. Okay, so one of it reacts with one of it to give one of it and one of it. Okay, so what do we have? Once that is reacted, we have got how much it was? X. There was X, so it consumed X HCl. Is that clear, guys? HCl is given in part B. HCl is given. How much is HCl?
1.2 millimoles.
Yeah, so this time there is no equation at all. X is equal to 1.2 millimoles. It's straight away given. So that's your first part and done, like done and dusted. So easy. Okay, so it is easier than the previous question. Okay. Phenolphthalein is already colorless in this thing. So it just had the HCl had to just make this become bicarbonate and it turns colorless. Now with methyl orange, what is the reaction? So we may take it as a fresh case and write freshly. So with methyl orange, Na2CO3 has to completely become your H2CO3 and NaCl. So it will be like two of it, right? Right, this is the complete reaction for methyl orange to show a color change. So how much was Na2CO3X? It will consume how much of HCl? 2H. Is that clear? Is that clear? And the other guy also has to react for methyl orange to show a color change. The other guy was NaHCO3 has to react with HCl to give you H2CO3 plus NaCl. This time the balancing is 1, 1, 1, 1, right? So this we have proposed that this is Y amount. So Y amount will react with Y amount of HCl, right? Right? So this time the equation is 2x plus y is equal to, how much have they said? 32 into 1 by 10. So 3.2. Okay, of which very luckily we already have the x value. So how much is the x value over there? It is 1.2. So 2 times 1.2 is 2.4. So y is equal to 3.2 minus 2.4. So y is equal to 0.8. Now for the actual question, what you'll have to do is to get the final answer and all, what you'll have to do is you have to say in that 1000 ml, that means in the 8 grams. Oh, so it is not even pure. Have they asked the purity or what? It may not even be pure. Okay. Why have they given the 8 grams? Okay. Let us see. So in that 1000 ml, in 25 ml, it is so much. So in 1000 ml, it is 40 times so much. Okay. 25 has got X. So 1000 would have got X by 25 into 1000. Okay. Okay. So Na2CO3 weight is equal to 40 into how much is the X? How much is X? 1.2. 1.2 by 1000 moles into the molar weight 106. Is that clear? Is that clear? Guys, just tell me how much this comes. Do a calculation while I write the other thing. NaHCO3 is equal to 40 times, how much was that?
Sir, I
0.8.
think the first one comes as 5.088.
5.88.
088. I'm not sure.
अरे कैलकुलेटर से करो ना, नॉट श्योर क्या. Okay, and NaHCO3, what is the molar weight of NaHCO3? Molar weight of NaHCO3? Yes guys, molar weight of NaHCO3, बोलो.
Sir, 88 something.
Something, by
Sir,
God
84.
man.
Sir, it's 84.
Huh? Yeah,
84.
84. Okay, so guys tell me what is the calculation, how much does it come?
About 2.7.
2.7.
Rounded off value.
Okay, so the total is less than 8 grams, so we are satisfied. Okay, they could have asked, a lot of things. Okay, so it is a hydrated thing, how much of water was there, what is the purity of this, whatever. Okay, this 8 grams is pretty much useless in this question, right guys? So end of story. If you have any doubt, ask me. Otherwise, sayonara, bye bye. Their answer is 2.7 and 5.28. So somebody told me a wrong calculation over here. Is it like 5.28 coming, guys?
Note 7, I got 5.088.
Okay, then they have written wrong. Okay, because it is our people who have typed. Okay, because it's the same thing. They are writing 1.2 into 106. They are doing the same calculations. Okay, into 4. Okay, so that's it. Anybody has any doubt? Anybody has any doubt? Anybody? Anybody? Do not copy the next question at all. This question you should do yourself, how much ever time it takes. First question you may copy. Second question, do not copy. Okay. Learning a certain question is not the objective. Okay. Finding a way of doing the question is the objective. You can take a screenshot of this one. Okay.
Thank you, sir. Bye, sir.
Thank you. Bye bye.
Sir, this is not related.